Okay, I'm quite certain this is going to be on your CBA, so let's make sure you understand how to do it. The homework that was due today over this, we're going to wait till tomorrow to grade it because so many kids are out today for NJHS. So let's go over the warm-up, and then if you have any questions on the homework, and then you're going to keep it, and we'll grade it tomorrow. All right, number 1. Who could tell me how to find domain from a picture? Look at the what? Look at the x values, okay? Of what points? For domain, what points do you want to look at? Or what part of the graph do you want to focus on? The left and right, because there's millions of points here. We want to look at the furthest to the left and the furthest to the right, because that's what x values do. They go left and right. So this point to the left is at -5, +1. This point to the right is at +5, +4. And if I'm talking about domain, all I care about is the x's. Now, one's colored in and one is not. Is that significant? Absolutely. So how would we write this domain? -5, less than or equal to x, and then just less than 5. Since this 5 isn't colored in, then I cannot put that little extra equal sign underneath this end of the domain. So -5 is less than or equal to x, which is less than 5 because this is not colored in. Are we good with that? What? The y's, the range. Let's talk about the range. You don't want to look at the left and right. You want to look at the top and bottom. So the highest point is this one, and the lowest point looks like this one right here. Now this point, we already talked about it. It's at, what did we say, 5, 4? What's this point at? +2, -6. And if I'm talking about range, I only care about the y's. And even if they don't put a nice big dot here, which they usually won't at the bottom of a figure, they usually don't put a nice big dot like I do. But it definitely is going through the -6 y value. So range, we would write -6 is less than or equal to y, but then what else? Is less than 4, because again, the 4 is not colored in. So that's the range. Remember, range should always have a y in it. Domain should always have an x in it. All right, number 2. Domain, again, you look at the left and right. This x value looks like -6 and it's colored in. This x value is at 2 and it's not colored in. So -6 would be less than or equal to x, which is also just less than 2. That's domain. Is that what you guys got? All right, range, top and bottom. Again, do you see how I did not put a nice big dot at the bottom? It's still going through that y value though. And I did this on purpose. Look at the top. This top number is colored in, but this one is not. And they're both at a y value of 2. This is at 2, 2, and this is at -6, 2. So the y value, the highest y value is a 2. If it's colored in anywhere, even though it's not colored in here, it is colored in here. So what kind of symbol should I use? Yeah, you got to put that little equal to symbol with it. So the lowest is -3, the highest is 2, and even though it's not colored in here, it is colored in here, so we do have to include it. All of the y's are in between, so we would use less than or equal to signs on both ends here. Are you with me? Isaac, you're looking confused. What part confused you? How? Did I say 3? It's -3. Okay, the lowest y value is, the lowest point on this graph is at the vertex, at the bottom. And I didn't put a nice big dot because they won't do that on the CBA. But if I look at this vertex, it's at -2, -3. So the lowest y value is a -3. That's where I got that. And the highest y value was at the top of the graph, which was a y value of 2. So for range, you got to look at the top and bottom. All right, let's talk about this one. My line wasn't very straight, but that's okay. Domain, the lowest domain value looks like -3 and it is colored in. What's happening to the right? It's going on forever to the right, but it stops at the left. So I can't put all real numbers. What do I have to put? No, not quite, because there's a whole section of numbers that are not included in this graph because it stops right here. It never goes lower than -3 ever. -3 is the absolute lowest, and then what do all the x values do from there? They get bigger. So how would I describe the domain? All of the x values are what compared to -3? Greater than or equal to -3. That's how I would describe the domain here. If it's got one endpoint, then you won't write one of those dealies where the x is in between something. And if it's got one endpoint, it can't be all real numbers. If it's got one endpoint, your answer would look something like this. You look at the endpoint and decide if the x's or y's are getting bigger or smaller than that endpoint. And these x values are getting bigger than -3. What if there had been an arrow on this one? Then it would have been all real numbers for domain because the left and right have arrows. But it didn't. It had an endpoint. Okay, so domain here is all of the x values that are greater than or equal to -3. How about range? Yeah, this one's kind of weird. The lowest y values all happen on this line segment, but they're all the same. What are the y values of this whole line segment? -1. So -1 is the lowest it will ever go. What's the highest it will ever go? 3. And all of the other y values are somewhere in between there. So the range would be -1 is less than or equal to y is less than or equal to 3. So some of the situations are kind of weird. You got to think about it carefully. All right, and then I threw in a horizontal and vertical line and line segment. Let's look at the blue one. What's the domain of this blue one? All real numbers. For the domain, you look at the left picked side and the right side. What do I see on the left? An arrow. What do I see on the right? An arrow. That means it never ends to the left and right. That's why the domain is all real numbers. The range is absolutely not all real numbers. The range, you look at the top and the bottom. Well, there is really no top and the bottom. There's just points on a line. But they all have something in common. They all have 5 as a what? As a y value. So the range is y equals 5. There is no other y value on this whole picture. No matter where I land on this line segment, the y value is a 5. Yeah, hold on one second. All right, let's talk about domain of this thing. Now, domain is left and right. This time, there's not really a left and right number. There's just points. They're all at what? 4. Now 4 is not colored in here, but is it colored in anywhere else? Yeah, so all of the x values on this whole picture equal 4. That's the domain. Range, you want to look at top and bottom. What's the top y value? 3. What's the bottom y value? And -1 is not colored in, keep in mind, and 3 is. So the range would go from -1 to +3. All the y values are in between. And on this end, on the -1, you're right, we would just use less than. But on the 3 end, we would use less than or equal to. Okay, so your homework today, I'm not picking up the homework that was due today. Were there any questions on that? Any of the pictures that you were kind of stuck on? This is the time to ask. All right, and your homework tonight is going to be more of the same. We're going to do a little bit of notes. I know there's a lot of kids out, but we still have to get through some stuff that's going to be on your CBA. We're running out of days here before Christmas. Indeed. All right. Let's get our notes out of the way. One thing I want to talk about is some more domain and range, and they did this on the CBA last year, so I want to make sure you're ready for it. They kind of throw all kinds of functions into the CBA at the beginning, and I don't really agree with that. I like to focus on one kind of function. We've been working with quadratic functions. These are different kind of functions. I gotta write you a pass. You gotta give me a minute. Alright, these are called exponential functions, but what you're going to need to know for the CBA is probably just identifying domain and range. And something kind of strange happens here. see if you can find the domain and range. I kind of think the opposite. I think the domain is easier. What do y'all think the domain is? Let's look at this picture. Okay, now remember, domain is left and right. Okay, but look to the left. What do you see? Yeah, the domain is all real numbers, because what do you see on the left and right? Arrows. If I look to the left and there's an arrow, I look to the right and there's an arrow. Domain of this guy is all real numbers. That's not the hard part. And this is where you got to listen, because this is some new stuff here. Range. Range is what could be tricky on a picture like number 1. Do you see how this end of the graph is getting really, really, really close to the x-axis? But it will never, ever, ever cross it. Yes. Okay, it's some new vocabulary here. If a line approaches, or if a graph approaches a line but never crosses it, that's called an asymptote. And they might put that vocabulary out there, so I want you to recognize what that means. An asymptote is when a function approaches a line but never crosses it. Let me look up a better definition. Honestly, this is the first time I've ever taught this. This is new to Algebra 1. Let's see if we can find a better technical definition. Okay, doesn't this sound smarter than what I just said? A line that continually approaches a given curve but does not meet it at any finite distance. It's never going to cross the asymptote. It gets really, really close to it, but it never ever crosses it. A line that continually approaches a given curve but doesn't meet it means it never touches, it never crosses. A line that continuously approaches a given curve but does not cross it. Yes, a line that approaches a curve but doesn't cross it. And they did have this on the end of course exam last year. My kids were so mad I had never told them that word. Or I mentioned it once, but we never really talked about it in depth. I didn't really think it's more of an Algebra 2 topic, but they've kind of shoved it down to Algebra 1. So the point of the whole identifying the range is it's never going to cross the x-axis. It's going to get so close to it you're barely going to be able to tell it apart from it, but it's never going to touch it. Okay, so let's think about that. The only thing it really affects then is how you write your inequality symbol. Range is top and bottom. So look at the top of this picture. What's happening at the top? It goes on forever above. It never is going to end as you go to the left. But to the right, it's never ever, it kind of does have an end point, or really an end line. It will never cross this x-axis. So what is the lowest y value on the x-axis? What's the only y value on the x-axis? Look at all these y values. What are they? 0. So this thing is approaching a y value of 0, but it never equals it. It never actually touches it. It never crosses it. It never goes lower than it. So how would I write the range then? It's not equal to 0. It will never actually touch. It's greater than. Would I put greater than or equal to? No, because it's never actually going to touch it. So the range of this guy is just y is greater than 0. The domain is all real numbers, but the range, all of the y values are above that x-axis. All of the y values are above 0. They will never actually touch, the x-axis, I'm sorry. They will never actually touch the x-axis. They will never actually equal 0, and they certainly won't go below it. So that range is y is greater than 0. All right, let's talk about this one. This one has an asymptote as well. The line that it's going to get close to but never touch is right here. What line is that? But what about 1? Is it x equals 1, y equals 1? This line is actually y equals 1. So the asymptote here is y equals 1. All of the y values on that line are 1. It's never going to touch that line, ever. It'll get super, super close to it. It'll never touch it. It'll never cross it. So let's talk about the domain of this thing. What's the domain? All real numbers. Because to the left and right, I see arrows. Range is not all real numbers, though. All of the y values are going to be above this asymptote, which is at 1. Good. So all of the y values here are greater than or, and not equal to, I'm sorry, just greater than 1. They'll never equal 1. They'll never touch that line. You see how the lowest y value I could see on this picture is, I really can't tell. It's not touching anything, but it's approaching a y value of 1. It's just never going to get there. Okay, this is a y value of 1 right here. All right, let's look at this one. I'm going to draw in the asymptote. It's just a kind of an imaginary line that the curve will approach but never touch. What's the asymptote here? Not just -1. Y equals -1. That's what this invisible asymptote is. It's a horizontal line at y equals -1. And this curve, this blue curve, will never touch it. It'll get super, super close to it, but it'll never touch it. What's the domain of this guy? All real numbers. What's the range of this guy? Y is less than, this time it's below the picture. So we would say y is less than -1. All of these y values are underneath -1, and they will never ever quite reach -1. Does that make sense? Question? Can you take the points on a parabola and turn it into the equation? Yes, and we will learn how to do that. That's pretty complicated, but we will get to that. Yes, question? Not right now. All right, I want to practice some more of that asymptote business. What's the asymptote here? Yeah, all the points on this little invisible asymptote here. I'm going to draw it in. Let me draw it in a different color. This is the horizontal line, and that line has a y value of 3 anywhere you're on that line. So this curve, the red curve, is approaching that asymptote, but it's never going to cross it. What's the domain of the red curve? All real numbers, because to the left and right I see an arrow. But the range is not all real numbers. Y is greater than 3. Will it ever equal 3? No, because that's what, it never touches an asymptote. Yes, there can be 2 asymptotes. That's really more of an algebra 2 thing. Let's try another one. Can you tell what the asymptote is here? Yeah, the asymptote here would be y. Let me do it a red this time. And again, it's kind of just an invisible line that's really not on the graph, but it's what the curve will approach and never touch. So this asymptote is at y equals -3. So what's the domain of the blue curve? All real numbers. What's the range of the blue curve? Y is greater than -3. Does that make sense? Okay, I was going to do quadratic transformations, but since so many kids are out and I don't feel good, we're just going to stop there. How does that sound? Now, the homework. There are some ones with asymptotes on the homework. Like, look at number 1. That's an asymptote 1. So is number 4. Number 7 is not, though. This is a straight line, and this is a straight line that's actually on. It's actually a horizontal line. It's not approaching it. This isn't a curve. This is 2 line segments. Do you see the difference? Okay. And then, of course, you got some that are just plain old points. is number 4. No, the y values are not greater than 0. No, you don't have to write the equation of the asymptotes, but you do have to write the domain and range. So the range here, you asked me, is that y is greater than 0. Right. It's below it, so it can't be greater than. It would be less than. All right, you can take a picture of this, or you guys will probably have time to do it in class. If you're watching the video, pause the video and do this homework assignment.